Hello everyone. Once again, a warm welcome to Success EduTech. I hope all of you are keeping your pace and studying the subject thoroughly. Today I have come up with the last lecture of chapter 1. Today we are going to deal with the concept of Newton's law of motion and momentum. This is the last lecture of laws of motion. In the previous lecture we studied about uniform circular motion. I request all the students to watch all the lectures of this chapter, Laws of Motion, in order to answer all the questions mentioned in the exercise of textbook Science and Technology for Standard 9th. Proceeding further, today we are going to deal with the three laws of Newton. These are the three laws of motion mentioned by Newton. The three laws are having very simple statements. We are going to deal with all the statements in a very easy manner. All the students have to do one thing. Learn those three statements. After learning those three statements, you are able to understand the meaning of the statement, and all the examples of the Newton's law of motion are in our day-to-day life. So need not worry about the explanation. Whenever a question of Newton's law of motion comes into the paper, just write down the three statements, give example of your day-to-day life, explain those example, that is it. You can very nicely explain the question. In order to understand the three laws of motion, we have to read these statements. Let us go through the statements. First statement: a static object does not move without the application of force. Yeah, whenever object is there which is stationary, it won't move. And until and unless we disturb means we apply some force. The force which is sufficient to lift a book from a table is not sufficient to lift the table. The fruit on a tree fall down when its branches are shaken. So when we apply some force, it will fall. An electric fan keeps on rotating for some time even after it is switched off. Why? Because there is certain some energy present in it, and the reason is it will keep on moving. If we look for a reason for above, we realize that object have some inertia. This is a new term for you students, inertia. Okay, we have learned that inertia is related to the mass of the object. Inertia, it is what? It is inability to move or change, an opposition to any certain change. I will give you one example of inertia. Whenever you are traveling in the bus, if a brake is applied or if the bus stops immediately, at the time you get a jerk. That jerk is because your body, the object, is having certain mass and it opposes the immediate change, so we get a small jerk. So Newton's first law of motion describes this very property and therefore is called as the law of inertia. So whenever sometimes they ask in the question what is Newton's first law of motion also called, so you should write it is also called as a law of inertia. All the instances of inertia are the examples of Newton's first law of motion. Proceeding further, Newton's first law of motion. First, we will read the statement. An object which continues to remain at a rest or in a state of uniform motion along a straight line unless an external unbalanced force is applied on it. So, here the concept of unbalanced and balanced force comes. So, the law has explained that the object, if it is stationary, it will remain stationary. If it is moving, if it is under uniform motion, it will be under uniform motion until and unless an external unbalanced force is applied to it. So balanced and unbalanced, there are two types of forces. To understand this, let us take the example of the tug of war. Tug of war, it is a common sports competition. In the sports competition arranged in the school, you have many activities. In that, tug of war is one activity. Whenever you play tug of war, what happens? So long as the force applied by the both the sides are equal, what will happen? That is balanced force. This is called as a balanced force. The center of the rope is static in spite of applied forces. Even though you apply the force, it will remain stationary. On the other hand, when the applied force becomes unequal, as soon as it becomes unequal, the team on one side becomes stronger. At that time, the force become unbalanced, and the team which is strong, which applies strong force, will win. Net force get applied in the direction of the greater force and the center of the rope shift in that direction. So you understand what is balanced force and what is unbalanced force. When the force applied are not equal, at the time it becomes unbalanced. So whenever there is unbalanced force, external unbalanced force applied to the object will start moving or it will change its activity. So when an object is at rest or in the uniform motion along a straight line, it does not mean that no force is acting on it. Actually, there are a number of forces acting on it, but they are acting on the same body at that time. They cancel one another, so the net force is zero. Okay. And Newton's first law explains the phenomena of inertia, that is the inability of an object to change. So you have the definition of inertia here. Inertia is the inability of an object to change its state of motion on its own. It also explains the unbalanced force which causes a change in the state of an object at rest or in uniform motion. So you have a concept of balanced and unbalanced force and a single statement of Newton's first law of motion. So we study here force, what is balanced and unbalanced force, and then proceeding further to Newton's second law of motion. In the Newton's second law of motion, the statement is the rate of change of momentum is proportional to the applied force. So we come across this force is equal to mass into acceleration. This is a statement, but we will understand what it is. Just I request students to perform this activity to understand the Newton's second law of motion. Actually, it is not required. Once you read it, you will come to know what is Newton's second law of motion, but just perform it so that practically you will get to know what is Newton's second law of motion. The effect of one object striking another object depends on both mass of the former object and its velocity. This means that the effect of the force depends on property related to both mass and velocity of the striking object. The property was termed as momentum by Newton. So there is a property which relates the mass and velocity. The property which relates only mass is inertia, which is having mass as well as velocity. At the time momentum comes into picture. Momentum, it is defined as the ability to keep increasing or developing. The force that makes something move faster and faster. Momentum has magnitude as well as direction. Its direction is same as that of the velocity, because the formula for momentum, they denote momentum as P. P is equal to mass into velocity. Mass is a scalar quantity. Velocity is a vector quantity. So vector quantity is having the direction. So the only term is the velocity which is having direction in the formula. So momentum will follow the direction of the velocity. Momentum is a vector quantity. Momentum is a vector quantity, whereas inertia is a scalar quantity. Remember that, because it is dependent only on one term, which is inertia, which is mass, and here the momentum is dependent upon mass as well as velocity. So it is having the magnitude as well as direction. In SI system, it is having the unit as mass kg, velocity meter per second. In CGS system, gram, centimeter per second. If an unbalanced force applied on an object causes a change in the velocity of the object, then it is called as causes a change in the momentum. Okay, there will be a change in the momentum is a unbalanced force is applied. Already there is an object with mass m moving the velocity v. If unbalanced force is applied to it, it will change. What will change? There will be a change in the momentum. The force necessary to cause a change in the momentum of an object depends upon the rate of change of the momentum. Momentum, it is what? It is the product of mass and velocity. P is equal to m into v. Now the rate of change of a momentum is proportional to the applied force, and the change of the momentum occurs in the direction of the force. This is Newton's second law of motion. Suppose an object of a mass m has an initial velocity u. Okay, so m is there, u is there, and the formula is mass into velocity. So initial momentum will be mu. When a force is applied, the direction of its velocity for time t, its velocity becomes v. So new or final momentum will become m into v, because momentum is mass into velocity. Rate of change of momentum will be what? Rate of change. That means there is a change in the momentum per unit time. It's like we call rate of change of velocity as acceleration. So we write v minus u by t for acceleration. Similarly, we can write final momentum minus initial momentum for rate of change of momentum divided by t. You can take m common, so it becomes v minus u by t, and we know that v minus u by t is a. So rate of change of momentum is equal to mass into acceleration, and the law says the rate of change of momentum is proportional to the applied force, and the change of the momentum occurs in the direction of the force. Okay, so mass into acceleration is what? The rate of change of momentum is directly proportional to mass into acceleration. So And what is mass into acceleration? It is force. Mass into acceleration is force. So F is directly proportional to ma because of Newton's second law of motion. And when you remove the proportionality sign, it becomes F is equal to K into ma, where K is a constant of proportionality, and generally we take its value as 1. So force comes out to be F is equal to ma. So you have to remember this one formula, and this is the second formula, and you have to remember this statement. That is it for Newton's second law of motion. Now, in SI system, the unit of force we know it is Newton. In CGS system, it is dyne. These 2 points you should remember. The Newton, it is nothing but mass into acceleration, right? Force is equal to mass into acceleration. So mass is kg and acceleration is meter per second square. When you come to CGS system, we call it as a dyne. At that time, in CGS system, the mass becomes gram and acceleration becomes centimeter per second square. So only you have to remember this thing because it comes as a question in your exam. You have to remember what is momentum, what is force, and what is the Newton's second law of motion. The rate of change of a momentum is proportional to the applied force, and the change of the momentum occurs in the direction of the applied force. Yeah, it will be in the direction of the applied force. Now, proceeding towards Newton's third law of motion. Read this question. Why is there a thick bed of sand for a high jumper to fall on after his jump? Because the jumper is going to fall with a very high speed, and then whatever is there on the bottom where he is going to fall down, it will give opposite reaction to it, and he will get hurted if the surface is hard. For that reason there is a thick bed. Yeah, so the Newton's third law of motion, it says every action force has an equal and opposite reaction for which acts force which acts simultaneously. Every action has an equal and opposite reaction which acts simultaneously. Okay, so this is the Newton's third law of motion. Very, very simple it is. You have to perform this 2 experiment as usual. You will come to know more thoroughly experimentally what is Newton's third law of motion. We have learnt about the force and its effect on the object by Newton's first and second law. Okay, we have learned what is force, what is the effect of force, that too we have learned. Now, however, in nature force cannot act alone. Force is a reciprocal action between two objects. Force are always applied in pairs. When one object applies a force on another object, the latter object also simultaneously applies a force on the former object. The forces between the two objects are always equal and opposite. Whenever there is force between the two objects, remember there should be two objects, so it will be always equal and opposite. If it is on the same object, equal and opposite force, it will get cancel each other. This idea is expressed in Newton's third law of motion. The force applied by the first object is called as action force, while the force applied by the second object is always called as a reaction force. Action and reaction are the terms that express force. Okay, like when you are hitting a wall, you apply some force. So at that time we get the same hurt back from the wall. If we hit a wall, so if we hit with a very high force, whenever we are talking about this example, we are always taking into consideration the term force. So action and reaction both are the terms related to force. This forces acts in pairs. Okay, and it is always between the two objects. One force cannot exist by itself. Action and reaction force act simultaneously. Action and reaction force acts on different object. When you talk about the example of hitting a wall, so your hand is one object and the wall is the second object. So there are two objects involved in the law. They do not act on the same object, and hence they cannot cancel each other's effect. While hitting a ball with a bat, the speed of the bat decreases. Why? Because the ball is exerting the revert pressure on the bat. Gun recoils, that is move backward when the bullet is fired. The gun will move backward and the bullet will go ahead. Mechanism of firing a rocket. Firing a rocket is the best example of Newton's third law of motion, because the satellite inside the rocket, it has to cross the ionosphere. So in order to cross through the ionosphere, a great force is required. When there is a propulsion of gas, this propulsion of gas is with a high energy and high velocity. The gas is propelled in the downward direction, which gives a force to the rocket, and the rocket moves in the upward direction, crosses the ionosphere, and it moves into the space. So mechanism of firing a rocket is based on Newton's third law of motion, equal and opposite reaction force. How will you explain this with the help of the Newton's third law of motion? So we have already explained these examples with the Newton's third law of motion. Now proceeding with the law of conservation of momentum. We have already understand the concept of momentum, which is ability to keep increasing or developing, moving more faster and faster. Suppose object A has a mass m1 and its initial velocity is u1. So whenever there is mass and velocity given to you, and we are under the concept of momentum is equal to mass into velocity, so its initial momentum will become m1 u1, and object B has a mass m2 and initial velocity u2, so its momentum of object B will become m2 u2. According to the formula for momentum, the initial momentum of A is m1 u1 and that of B is m2 u2. Suppose these two objects collide each other, so at that time a force is applied on it. Let the force on A due to B be F1. This force will cause an acceleration in A and its velocity will become V1. So momentum of A after collision will become M1 V1. Similarly, the momentum of B after collision, it will become M2 V2. And the two forces are F1 and F2. These two are equal and opposite forces. So the reason there are two signs. One is equal to sign and another one is negative sign. This negative sign is taken because the two forces which are equal are in opposite direction, and we know the formula of force is mass into acceleration. So simply substitute the value m2a2 is equal to minus m1a1. This is because of the formula of F is equal to mass into acceleration. Acceleration formula we know, that is final velocity minus initial velocity divided by time. So v2 minus u2, because it is for object B, v2 minus u2 upon t, v1 minus u1 upon t, mass is multiplied with them. Simply cut this two t's because the time t, it is equal quantity in both the sides, and then after cancelling the t, rearrange this term, you will come to the conclusion that m2v2 plus m1v1 is equal to m1u1 plus m2u2. So we can say that the magnitude of the total final momentum is equal to the magnitude of the total initial momentum. This we have to prove using law of conservation of momentum. Thus, when no external force acts on the two interacting body, their total momentum remains constant. The momentum is always constant. It does not change at all. When the two objects collide, the total momentum before collision is equal to the total momentum of after collision. So in any case, in the case when there is no external force, or in case when there force exists between the two colliding bodies, in any case there will be law of conservation of momentum always. So as the mass of the gun is much higher than the mass of the bullet, whenever we fire a bullet from a gun, what happens? The bullet will move. It will move with a greater velocity, but and to a very long distance. As the mass of the gun is much higher than the mass of the bullet, the velocity of the gun is much smaller than the velocity of the bullet. Bullet will go to very far distance, whereas the gun will come backward to a very small distance. So why? Because the mass of gun is much higher than the mass of the bullet. So equating both the sides, what we will come to know, that the momentum will remain the same. The magnitude of the momentum of the bullet and that of the gun are equal in the direction of opposite, because bullet has got higher velocity, less mass, gun has got lower velocity, high mass. So in both the cases the magnitude of the momentum will remain the same. Thus the total momentum is always constant, whether you talk about gun or you talk about the launching of a rocket. Let us go through some solved examples. The mass of a cannon means in Hindi we call it as a top. So the mass of a cannon, it is 500 kg. It is very heavy in weight, and so immediately write down the mass in the given quantity, and it recoils with a speed of the 0.25 meter per second. Speed is given to you, mass is given to you. They have asked you to calculate the momentum. Momentum is equal to mass into velocity. At the time, just substitute the values given in the given. If you write the properly the given quantity and what is asked, write the formula for what is asked, you will surely get the answer, which is 125 kg meter per second. In the second example, two balls have masses of 50 gram and 100 gram. M1 and M2 is given to you. They are moving along the same line in the same direction with a velocity of 3 meter per second and 1.5 meter per second. So these are the initial velocity because they are moving initially. So U1, U2 is given. They collide with each other, and after the collision, the first ball moves with the velocity of 2.5. That means V1 is also given. They have asked you to calculate the velocity of the other ball. So we have to calculate V2. So after writing the given quantity, immediately you come to know that this is a question of law of conservation of momentum. So we already studied that m2v2 plus m1v1 is equal to m1u1 plus m2u2. Use this formula, substitute the given quantities, solve the question, solve this entire equation, and you will come to know that the velocity comes out to be 1.75 meter per second. So I request students to take pen and paper and simply write down the given quantities, write down what all things are required, write down the formula for that, substitute the value, calculate it properly. You will surely get the answer. If in case you don't get the answer, let me know about it. I will surely solve and give you on paper. In short, what we have studied is Newton's law of motion and law of conservation of momentum. You have studied law of conservation of momentum as well. Okay. In any case, the momentum, initial momentum and the final momentum will remain the same, and the 3 Newton's law. In the entire lecture, what we have to remember is the 3 laws of motion, Newton's law of motion, and 1 law of conservation of momentum. Only 4 statements you need to remember. Give the example for the for each and every law. Whatever the example are there in your day-to-day life, explain it. That is enough for this question. And you have, in this chapter, you have only simple question related to Newton's law of motion and related to the equation of conservation of momentum, and some example based on equation of motion, the 3 kinematical equation of motion, and single formula of acceleration, which is equal to final minus initial velocity divided by time. Only with this few formulas you have the numericals related. I request students to solve all the questions mentioned in the exercise of your textbook. Just try to solve the questions, write down the answers. If in case you are not able to solve these numericals mentioned here, just let me know which question you are not able to solve in the comment section. All the comments in the comment section will surely be referred, and each and every question, in case if you are having doubt with it, will be solved and provided to you. Just go through all the question once and try to solve it. Watch all the lectures thoroughly. You will be able to understand the concept. Thank you for watching. Don't forget to like, share and subscribe.